So it's been a while since I've done any much electronics tinkering, but I find myself with a little more free time now. So I was struck with finally the idea of building a robot. Originally I was going to build an autonomous robot, which I probably still will do at some point, but then I decided I might actually try to make a remote control one first. Not really because it's simpler or more difficult, just because the inspiration struck, I guess. So what I've done tonight so far, is just a little testing on the RC receiver and basically the insides of this toy car that I bought. You can see the deconstructed toy car here and some of its bits sitting around. But what I got set up here is I basically stripped everything out of it, and just to make sure that everything was still functioning properly, I am powering it off of my Arduino out of one of the 5-volt pins. The car had a spot for three AAA batteries, so for 4.5 volts in its own carriage. But so 5 volts is a little high, but not too high. And I'm actually in the final build of the RC bot. I'm not even going to be using these motors, so the leads that go to the motors now will actually just be used to trigger the motor. Will be used to trigger the actual Arduino into activating the motor controller. So here we can see I have the remote that came with the RC car, and really this is just powering off the Arduino. But you can see we still get the front and the back motor still still kicking, and then the motor that was used to control the steering. You can't see it terribly well, the focus, but you can see that the motor's spinning there. So basically just showing we're getting good signal from the controller still, the remote. So the next step will be to actually interface these leads that go to the motors now back into the Arduino, and make sure we're getting some kind of usable signal from that. Alright, so I'm back with the second part here. After a little tinkering, I've got the receiver module from inside the remote control vehicle still being powered off the Arduino, but now I have, instead of being connected to the motors, the four main wires coming off the receiver into the breadboard are now hooked into jumpers, which are connected to pins on the Arduino. I was having a little bit of issue with a couple of the leads from the RC receiver constantly sending signals constantly instead of changing whenever the button's in the off state. So I pulled back in my memory of working with buttons and added a couple of pull down resistors for those two. I did some basic code to basically output the information that the Arduino is receiving from the wireless, and having it print to the serial monitor. So you can see here I have it default as printing blanks, but here I'll start pushing buttons on the controller. So you see I'm holding down forward now, so I'm getting good signal wirelessly there, and then left and right. So once again, all that is me pushing the controller, and you can see there in the background the corresponding left, right, forward, and back. So far it's good. I believe this will work just fine for being the receiving unit that will send signal to the Arduino, which will control the motor drivers and hopefully function the robot successfully. So I'll be back with more updates. Alright, so here I have the next step of the testing of the RC unit adapting into the Arduino. What I've done here is added these 4 LEDs here, which are attached to 4 pins here on the Arduino. And what these are meant to represent is the motion of the left and right track on the eventual tank vehicle. The red LEDs in the front indicate forward motion on the left and right track, and the yellow LEDs in the back indicate reverse motion for the left and right track. For instance, if the tank wanted to travel forward, then the front two red LEDs would both be active at the same time, and for a reverse motion, the back two yellow LEDs would be active. Now, because this is a tank, the turning motion is a bit counterintuitive, because on a tank, in order to turn left, the right track must be going forward and the back track must be going left in order to rotate in place, and vice versa for a right turn. So, we can see here, I've modified the code obviously to take into account these changes, but we can see here pretty quickly that still with my wireless transmitter here that came with the remote control car. So now if I push forward, you can see that the front two LEDs light up. That right one's a little dim. I think it's a little burned out, a little damaged, but you can still see it lighting up there. And then if we do a backwards motion, you can see the reverse. So that would be a straight back of the tank. A left turn would be the front right, or the right track rather, rotating forward, the left track rotating backward, and then the opposite, a right turn, would be the left track rotating forward and the right track rotating backwards. So far so good. The code I've used on this setup will be able to be adapted pretty easily, if not directly, for interacting with the actual motor driver integrated circuits that I've yet to receive in the mail. But I just want to run through this and make sure that all this proof of concept is working. So it seems like this remote control receiver that I pulled out of that poor $8 RC car is working very well. It's very easy to figure out how to interface the 4 leads that were on the motors into this setup. So if anybody's looking for a cheap and easy way to get some wireless power onto your device, I would definitely recommend hitting up Radioshack and looking for their small RC cars. So be back with the next video, hopefully with this actually operating the tank, or the tracks at least, so you can see it in action.